In a bold revelation, scientists have announced the discovery of a planet unlike anything we've encountered before. NASA, known for its revolutionary space research, has revealed that this planet stands out not just because of its unusual size and location, but also due to strange lights on its surface that appear artificial. This discovery raises profound questions. Could these lights hint at something more? Are we close to unlocking secrets that might redefine our place in the cosmos? Could this be evidence pointing toward life beyond Earth? To understand the origin of these mysterious signals, we turn to one of NASA's most remarkable missions. In 2007, NASA launched the Dawn spacecraft, an ambitious project aimed at exploring some of the most intriguing bodies in our solar system. Powered by three ion engines, Dawn was able to embark on a journey few spacecraft could achieve. Its first target was Vesta, the second largest object in the asteroid belt, where it spent 14 months capturing high-resolution images and gathering detailed data. These observations revealed Vesta's complex terrain and diverse geological history. Once its mission at Vesta concluded, Dawn moved on to what would become the highlight of its journey, the dwarf planet Ceres. The transition between these celestial bodies was made possible by Dawn's ion propulsion system, which allowed the spacecraft to exit Vesta's orbit and set course for Ceres, something that traditional chemical propulsion would not have been capable of. These gentle, continuous thrusts enabled Dawn to travel great distances and enter a stable orbit around Ceres. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, is the largest object in the asteroid belt located between Mars and Jupiter. Although once considered the smallest planet, it was reclassified as a dwarf planet in 2006. With a diameter of approximately 950 kilometers, Ceres is not only the most massive body in the asteroid belt, but also one of the most intriguing. Due to its distinctive features, scientists were eager to receive the first detailed images of this mysterious world, and what they saw exceeded all expectations. The surface of Ceres revealed bright, reflective spots, most notably within a large crater named Okator. These luminous features caught the immediate attention of researchers around the globe. Before Dawn's mission, the best image of Ceres came from the Hubble Space Telescope, which only offered blurry, low-resolution views. Little was known about the dwarf planet, and the opportunity for a close-up look held the promise of groundbreaking discoveries. One of Dawn's key goals was to deepen our understanding of the solar system's formation and the role water played in the development of planetary bodies. The bright spots observed on Ceres, similar to features seen on some other asteroids, might be composed of highly reflective materials, possibly salt deposits left behind as water sublimated. This process hinted at the presence of cryovolcanism, where icy volcanoes erupt liquid water or brine rather than molten rock. These strange lights begged for an explanation. What were they? Could they indicate active geology, or was something even more extraordinary at play? Ceres distinguishes itself from other bodies in the asteroid belt not only because of its size and mass, but also due to its unique composition and potential to hold water and ice. Unlike most asteroids, which are predominantly rocky, Ceres has a composition more similar to a comet, suggesting it might offer valuable insights into the early solar system. After a 2-year journey, Dawn began its approach to Ceres in early 2015. This marked a significant milestone, as it prepared to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn got closer, the images it sent back grew increasingly sharp, revealing a cratered landscape shaped by countless impacts over billions of years. But it was the strange, reflective spots nestled in the darker, rocky terrain that sparked the most interest. With higher image resolution came a flood of theories. Were these bright patches simply ice reflecting sunlight? Or could they be something more exotic? The most prominent of these spots turned out to be clusters of multiple reflective features rather than single glowing points. The leading theory suggested that these were salt deposits left after water or brine reached the surface and sublimated, leaving behind shiny mineral residues. This pointed to a world far more dynamic and geologically active than previously thought. The possibility that Ceres contains underground water or pockets of brine holds major implications for the search for life. The dwarf planet is often described as an icy body with a porous surface, differing from most asteroids made mainly of rock and metal. Ceres's surface contains a mix of water ice and hydrated minerals, such as clays and carbonates, giving it a lower density and hinting at a subsurface reservoir of water. This unique makeup suggests Ceres might have once harbored, or may still, host, liquid water beneath its surface. Its internal structure likely includes a muddy mantle surrounding a core rich in water ice, accounting for up to half of Ceres's total volume. Radioactive decay in the planet's early history could have provided the heat necessary to maintain liquid water internally. These factors distinguish Ceres from its rocky neighbors and raise fascinating questions about its geologic activity and the role of water in its evolution. Additionally, the detection of ammonia-bearing clays on Ceres provides further clues to its past. This suggests that Ceres may have originated in a colder region of the solar system and later migrated inward. The presence of ammonia, which lowers the freezing point of water, could support the existence of surface brines today. These findings don't just deepen our understanding of Ceres, they also help us learn more about the processes shaping icy bodies throughout the solar system. Cryovolcanism, a relatively rare and little understood geological phenomenon, plays a key role here. Unlike a volcanic activity on Earth, which involves molten rock, cryovolcanoes erupt substances like water, ammonia, or methane, materials that can remain liquid in extremely cold environments. On Ceres, these ice volcanoes may bring salty water to the surface. Once exposed to the vacuum of space, the liquid sublimates, transitioning directly from a solid or liquid state to gas, leaving behind reflective salt deposits. These deposits are what form the bright spots, with the most famous cluster found in the Akater crater, specifically in an area named Cerealia Facula. This region is highly reflective and has even exhibited transient hazes, possibly caused by ongoing sublimation of water, suggesting that cryovolcanic activity might still be taking place or occurred not long ago. Beyond Akater, several other bright spots have been observed across Ceres's surface, each with distinct characteristics. Their wide distribution indicates that cryovolcanism may be more common on Ceres than previously believed. These discoveries have fundamentally altered our view of Ceres, revealing it as a geologically active world rather than a static, frozen remnant of the solar system's past. As Dawn continued to relay detailed images and data back to Earth, more and more surface features became visible, adding to the richness of Ceres's story. Craters of all shapes and sizes cover the dwarf planet, each offering a glimpse into its long and varied history.